Alright, we are in lesson 2.5, dilation. So let's look at this first thing. I'm going to do my Starbucks for some people on these, because I'm not suckers. So, these little nesting dolls, that's what those little Russian dolls that they fit inside, are they congruent? Zach?
Yes.
Okay, why yes? 50,
Or
50
no,
shot.
they're not.
Okay, why no?
Because they're different sizes.
Okay, what's that matter?
It's not the same. It's not the same thing.
Good. Well, they're the same shape, right?
Yeah.
But in order to be congruent, we have to have the same size and the same shape. They're the same shape, but their sizes are different. Same thing with the giraffes. They might look the same, but different sizes. The cars, one's a model car, one's the real car. So they're close to being the same, but right now they're not congruent. Has anyone ever put together like a model car or built something like a little bridge or a house or anything? Yeah, so when you guys have done that, have you ever noticed that they say like scale, or even on TV when they show commercials, they might say, oh, this is not to scale. Or they say the scale. When I made a model car with one of my kids, we made a pickup truck, and it was like 1 to 64. Well, that scale meant whatever I measure on there, on that little toy car, is 64 times as big on the real car. So they showed me the scale. They're showing how the toy one is smaller and the big one is 64 times as big. So when I look at here, this is what we're going to work on, changing the size of a figure according to a scale. So it says, did the size or shape of the figure change when we performed translation, reflection, and rotations? Yesterday, we worked with translations, rotations, reflections. When we did any of those three, did we change the size or the shape? No. When I slide something, when I turned it or I reflected. So the answer there is no. And for the extra points, the ones I'm going to do at Starbucks, can anyone tell me, what is that called? What did we call yesterday the translation, reflection, rotation? It was a 2-word. Do you remember it?
It was like something sliding. I forgot, whatever.
Should be in our little folder if you don't remember. It's 2 names. What would they have been? No, congruent figures. We make congruent figures, but what's it called when we did a translation or a reflection or a rotation?
I'm going to use right here. Is it rigid motion?
Rigid.
Yeah.
Motion. I'll give you both points. Rigid motion is what happens when we do our translations, our slides, our reflections. Okay. If you go to an eye doctor, which actually my wife was just talking about, she's going and I have to go soon for a little eye test. They dilate your eyes, right? They always talk about dilation. They take those little drops. I know.
That was hard.
Wait, what?
I had to play soccer and I was playing goalie and my eyes were
Yeah.
dilated. That was so hard.
And I did that before where they dilated my eyes. So what happens is they put those little drops in and it makes your pupil get really big, right? So when we dilate your eyes, it means that they're taking the size of your pupil and they're making it bigger. Well, we're going to use the exact same thing. That'd be really freaky if this was just her normal eyes.
Ooh, why is that chick's pupil so tiny?
Well, because she only did one.
Okay, no, but nobody's pupil is actually that small.
She did cocaine.
Your pupil,
If you shine a light to it, like
your pupils, the pupils kind of act like a camera. So how much light they let in. If you ever want to test this, I remember doing this in elementary and I always thought it was cool. If you go into like your bathroom and you put your hands right over your eyes so it's real dark, you just sit there for a few seconds and look in the mirror and then open your eyes quick, you'll see your pupils go from real big to real small. Now,
She's like automatic.
they will get small when it's really bright outside. Yeah, your pupil closes and gets small, not to let as much light.
Like a cat.
Why does it do that?
Alright, so here's what we're going to do. Here's how we're going to do our exploration. Today our goal is that I can dilate figures in a coordinate plane. Okay, I I need everyone to turn in their notebooks to the part that you're going to work with a partner and you're going to get some points here. But we need to turn to dilations right here. I think I got to give that. Where did I put the ones today? Okay. Everyone should get to these 2 pages. And this is going to be your exploration. You're going to work with a partner. You're going to be using your computers. You're going to be doing this. I'm just going to show you how first. And then I'm going to have you guys work on this is what I'll award Starbucks on. It says, lesson 2.5, exploration. This is supposed to be you doing it more than me. I'll give you the link, and you're going to answer these questions below. Now, to do so, I'm going to go back to mine. When we go to that link, it's going to give me this. Here's our triangle. So for everyone in your notebook right now, we can go ahead and record the coordinates of triangle ABC. It is 1, 1, 3, and 5, 1. Okay, these are our 3 coordinate points. So on that page, make sure you write these down. We're going to use them on each and every one. The goal here, I'm going to ask you a question at the end of this, and you're not going to be able to use this computer. To be honest, I should be able to use this and change the scale and get the answer, because it's going to be physically shown to us. Remember, the reason we use tracing paper, the reason I've been giving it out to you, is so we can learn the rules, we can see it, we can manipulate, turn, and do something to see the rule. But we're supposed to be learning the rule, because we won't always have tracing paper. For here, we're going to use this program to learn the rules about scales. Once you've learned it, you won't ever need this. You will know the rule of how to do it. Okay? So, I'm going to have you, on your paper, you're going to go ahead and answer numbers 2 through the bonus. We'll come back in about 5 to 10 minutes and discuss it and see who can answer them for their Starbucks and what we've learned. And then I'm going to give you a bigger bonus where you can't use a computer. So, to get to the link, you do need to open up your laptop. You can go to your OneNote. And when you go to OneNote, make sure you're on 2.5. The link is right here. I can go to this website. Okay, the link's on OneNote. You may work with a partner if need be. The goal is in the next 5-10 minutes that you have figured all this out. So if you're just messing around, I'm going to mark you down for being off task. Otherwise, work at this, see what we can learn. Alright, so let's talk about this and see how well you did. So the first thing is, on the very first one, number 2, we changed these still. My coordinate points are still at 1, 1. B was at 5, 3. C was at 5, 1. When I went to here, and I changed my scale to 2. Now here's the first thing I want to point out. When our original scale was at 1, that's where we always start. When we're at our original, we are at 1. Okay? 1 is our starting place. So when I went to 2, what happened to my triangle? It got bigger. So if you want to write this down in your notes, I would do so. I'm going to go ahead and put just a little side note that I'm going to put X in. So X is going to stand for my scale. If my scale is larger than 1, what do you think will happen to my picture?
It'll get bigger.
Yeah. So anything, if I ever make my scale bigger than 1, we are going to get a bigger image. So when I went to a factor of 2, you guys should have done it this way, and I can see that my triangle actually got bigger. What were my new coordinate points? So my original was 1, 1. All right. So for my side, Ainsley. What would have been my new A? Okay, it would have been 2, 2. B is, and C is perfect. So if I look at those, give me your Starbucks. What operation did I do to get from my first triangle to my second triangle? Ryan? And what did we multiply by? Alright, so when we are doing scales and dilations, if I change the scale to something greater than 1, I am going to multiply it by that number. So if I look at number 3, original A was 1, 1, 5, 3, 5, 1. If I change our scale factor to 3, first thought I have is 3 larger than 1? Yeah. So I'm going to use what Ryan just said. Instead of actually drawing this, or if I do have to draw this, and they gave me the picture and said, hey, we need you to draw this to scale, and the scale is 3, Tegan. Done. How would I find my coordinate points? What should these be?
Multiply.
Avery?
It should be 3,
3, 3,
2, 2.
15, 9. So all we did there was you take every coordinate and you times it by your scale. If we look here, I physically go ahead and change that, and we can check. Yeah, it was 3, 3, 15, 3, 15, 9. It matched up with everything that we said it should be. So, obviously, we multiplied by 3. Number 4 is tricky. There's something important about it. Our scale was 0.5. Did anyone physically do that and look to see what happened?
No, it's really good.
So what did it do to my triangle? It made it smaller, right?
Yes.
But here it is. How do I know if it makes my triangle bigger or smaller? Why was this one smaller, Ben?
Because it's smaller than 1.
Okay, let's put this note in. If our scale is less than 1, this one, it was less than 1. So anything between 0 and 1, it was going to make my triangle smaller. This happens anytime with our dilations. If our scale unit, our base is 1, that's where we start off at. Anything less than 1 is going to make it smaller. Now, remember, 0.5 is the same. Multiplying by 0.5 is the same as multiplying by 1/2. It's also the same as dividing by 2. It's important in math, you guys will see when we get into more algebra stuff, that there's times we use these 3, just kind of switch around. If I need to multiply, then I use decimal 0.5. Sometimes when we're working with fractions though, it works easier to times it by 1/2. 0.5 and 1/2 is the same amount. Other times I need to divide by 2. And that's it. I won't keep crazy forward and do your work, please. So, if I look at this one, and we had our points, what would be my new coordinates? I know my scale is 0.5. So what would be my new coordinate points for A? Without visually looking at it, what would we get, Ryan?
0.005.
Read this.
Okay, if we got a half and a half of 1, it'd be 0.5. What about B?
2.5 and 1.5.
Troy, have your pointer out. So 2.5 and 1.5, and 2.5 and 0.5. Okay, well, it's not too bad. We just have to realize that if we're greater than 1, we make it bigger. We're multiplying. If it's less than 1, we can still multiply, but it's going to make it smaller because we're going by a fraction. So I still had our multiply by a half or 0.5, or you could have said we would divide by 2. All right, here's the bonus. And this is going to lead to our big discussions. If we change the scale factor to -2, we notice the biggest change is it's no longer a positive number but a negative. Now, if you haven't done this yet, it's okay, don't do it. Let's just talk about it. Do you think my triangle will get bigger or smaller in size?
Smaller.
Bigger. Large, bigger.
Okay. Why do you think it will get smaller?
Because it's putting it in the negative.
Okay, but is the triangle size bigger or smaller?
It's bigger.
Big.
Bigger.
It is big thick.
Hey, you know what? The original
So,
triangle.
yeah. So if we look at this,
Bigger than
it is,
What?
it's making our triangle bigger. And that should be pretty simple to understand because we can go ahead and say my scale, even though it's -2, that 2, we're looking at the absolute value of it. That triangle is going to be twice as big as the original one. So my triangle is twice as big as the scale was with the 2. It's twice as big. But what did the negative part do? The negative, if we went ahead and we wrote down our coordinate points the same, and I times by -2. Well, that means these were all positives, and a positive times a negative is negative. So I'd have -2, -2, -10, -6, -10, -2. And we said, what did that negative do? It's going to change quadrants. A negative scale will rotate image. And it rotated our image 180 degrees. If we think about that, for this one, it rotated it from quadrant 1 to quadrant 3. It went 1, 2 turns. If this triangle would have been over here, these were negative positive. So when I times, I would have still got over to the positives for the x, but negatives for my y. It still went 1, 2 turns. So we have to still, the biggest thing is, multiply by the scale. So here's what I'm going to do. I'm going to give a bonus of 5 Starbucks this up in a second. What I want you to do is go ahead and close your laptop, because you're not going to be able to use it for this bonus. Okay. All right. Put your name on this. Alright. Put your name on this real quick. I'm going to give us. I'm talking about Zachary. How are you not coming across prepared?
Yeah, I finished. I finished.
Alright. What?
What did that hit?
And also, I
What did that
do
hit?
Alright, so.
Did I leave my laptop in here?
Yes.
Did you find a laptop? Because the sticker on my
Nope. Alright, listen up, guys. Guys, we're making this difficult, but it's pretty simple. Alright, on your paper, put your name. Put your name, and then at the top, I'm going to tell you to put a 1 or a 2. So, let's just do it. I'll trust you guys. Someone. Parker and Alex, please pay attention. Everyone's name should be on this. This is going to be your bonus.
No bonus.
Okay. Okay, write this down first. This is going to be your starting point. Everyone's going to write this down. The triangle that I have graphed is located at point 1 is 1, 2. B is at -3, +4. And C is -2, -5. So I've made a triangle. Zachary, why don't you come sit back at your spot? I know you're running out of paper. I need you to come sit at your own spot. Thank you. So, I'm going to give you 2 prompts. Each one of these is going to be worth 5 Starbucks if you show me your work correctly and get the correct answer. I'll write this up in just a second. After you finish, I want to collect your paper. I'll look at it. And then you can work on your homework. Your homework is something fairly easy. I want you to look up here so I can explain it real quick. Your homework is 2.5 dilations day 1. On 6, 7, and 8, you're telling me what was the scale. So it says point A was at 8:12. When they did the dilation, it came out to 16:24. So how did I get from 8:12 to 16:24? Obviously, we took it times 2, so that means my scale was 2. When you do 7 and 8, they're telling you that the points were 2, 3. And 6, 9, you have to tell me what would this scale have been. Parker, please pay attention.
Stupid.
On 9, 10, 11, 12, 13, and 14, very easy. Yes or no, is it a dilation? That's all we need to put. Alright. Okay, here's your bonus. For your bonus, I need to find out what would you have said are the coordinates if my scale was -3. And for the second one, if my scale was 4. This is your bonus. Turn it into me as soon as you get done. and then work on your homework. That's what we will grade for tomorrow. Yes, but there's no hard problem.
These are coordinates, the first one.
Yep, every time use the original coordinates, which are the blue ones. So, here's the original in blue. What would it turn into using the green one? Then go back to the original, and what would the orange come out to? Right there. Nope, no computer.
The green one.
Okay, put them all down, and then you're going to put them into me.